Okay, another thing we want to introduce with functions, one that we see quite often, is called piecewise functions. So piecewise functions are different functions for different parts of the domain, so meaning different x's. So they're usually written kind of in this form where they have f of x equals, and it tells you which function goes with each part of the domain. So when my x is less than -2, I would be using this function of x. When my x is between -2 and 2, equaling them even, I would be using x squared. When my x is greater than 2, I would be using x cubed. And in order to illustrate how to use it, let's go ahead and try to graph this one so we can get an idea how to use a piecewise function. So in order to graph, one of the ways we can graph is just by plotting points, so we're going to do that this time. And we're going to plot some points, and we're going to say, well, we're going to have to be pretty careful with what points we choose, because we have a lot of rules over our different x's. So I'm just going to start off with this first part of the piecewise function, and I'm going to try to plot some points where x is less than -2. So I'll make this my x, this my f of x, and this time my f of x is x. So let's see. I'll do, I guess, -5, -3, and I'm going to go ahead and plot -2, even though it can't equal -2. That is an endpoint, so I kind of want to see where it actually ends. So if I do that, if I sub in -5 for x, and I'm going to get -5 for my f of x or my y, because we're graphing it, you might want to think of it as a y. -3, I'd get -3, -2, I'd get -2. And I'm going to put these on my graph. So if I have -5, then that's going to go x being -5, y being -5, it'd be down here and it'd be a point. If I have -3, and -3, it'd be down here and it'd be a point. If I have -2, it'd be at -2, -2, but it wouldn't be a point this time. Because it can't actually equal -2, I'm going to do what we were doing when we were doing the number line with inequalities, and just put an open circle. It'll be helpful if my cat is not in this. Seriously, dude, move. So I'm going to start at the -2 and just connect my points. Okay, so that's what that part of this graph looks like. We'll draw my arrow up here so you can see it better. There. Okay, so let's do another one. So let's do the points, I guess, between where x is in between -2 and 2. So I'm going to go ahead and do, since it hits -2, I'm going to do -2. I'm going to do 0 because I always like to know my intercepts. And I'm going to do +2 because it also hits there. So this time I'm using f of x equals x squared. So if I sub in -2, I'll get 4. If I sub in 0, I'll get 0. If I sub in 2, I'll get 4. So I can plot these. -2 is up to 4. 0 is at 0. And 2 is up to 4. It kind of makes sense at a bend, since I remember that x squared is a parabola. And I used dots for everything this time because, well, it also equaled. So I'm going to draw in my parabola. Okay, I'm going to go ahead and try to graph the last part of this. So x is greater than 2, so I'm going to pick stuff greater than 2, and I'm going to pick, again, 3 and 5. And I'm also going to pick 2 just to kind of see where it starts off at. F of x equals x cubed, so let's make sure I'm using the right function. 2 cubed would be 8. 3 cubed would be 27. Oh man, 5 cubed is 125. So I'm just going to kind of get an idea of how this goes, because this is going to be really quickly really big. So my 2 would be all the way up at 8. I didn't even go to 8. So 6, 7, 8, all the way up here. Drawing a circle, not an open circle, not a dot. And then 3 at 27 would just shoot up, right? So I'm going to go ahead and just draw this thing shooting up. 5 at 125 would shoot up even more. So I'm going to draw this shooting up and just draw an arrow to show that it continues going all the way up that way. So that's how we can use piecewise functions, and that's how we can graph them. Move it up so you can see the whole graph, I guess.